My name is Matt Gordon, and I'm a Senior Applications Engineer with Micrium. Micrium is an embedded software provider offering a complete lineup of modules, the best known of which are the real-time kernels MicroCOS2 and MicroCOS3. Micrium is also one of Renesas's Platinum Partners and is a proud sponsor of this year's Renesas Developers Conference. At the conference, there will be a number of classes covering Micrium software, including one that I will be teaching titled Getting Started with a Real-Time Kernel. Just as the name indicates, this class will provide a primer on the use of real-time kernels in embedded systems. Real-time kernels can be exceedingly helpful to software developers responsible for combining a multitude of different features into a reliable, smoothly running product. A surprisingly large portion of the embedded community, however, remains unaware of the benefits of using a kernel. In my class, I'll provide the background information that developers need in order to begin taking advantage of all that real-time kernels offer. I'll begin by explaining what exactly a kernel is. Although some developers assume that a real-time kernel is the same as a real-time operating system, or RTOS, there are significant differences between the two. A kernel is actually just one component of a real-time operating system. In the class, I'll clearly explain what services a typical kernel does and does not provide. After I've defined what a kernel is, I'll provide the class's attendees with a detailed look at what can be considered the primary function of a kernel, task management. A kernel provides developers with a framework for dividing an application into multiple different tasks. I'll discuss the contents of a typical task, and I'll reveal how the kernel decides which of a developer's tasks should run at a particular time. I'll also cover the details of a context switch, the process by which a kernel switches from one task to another. Following this in-depth look at task management, the focus of the class will shift to some of the other services that kernels offer. These services include task synchronization, mutual exclusion, and inter-task communication. In discussing these services, I'll cover many of the objects that developers commonly associate with kernels, including semaphores, mutexes, and message queues. I'll explain how a kernel's different services can be used to develop robust and dependable multitask applications. Since the best way to become familiar with a real-time kernel's services is actually to use those services, I've prepared multiple coding exercises for the class. Through these exercises, attendees of the class will have the opportunity to gain experience writing kernel-based application code. Approximately half of the 4-hour class will be devoted to these exercises. The hardware platform that attendees will use to run the exercises will incorporate a device from Renesas's new RX family of microcontrollers. The class, however, is not intended solely for developers who are using an RX device. The majority of the class's content applies to all Renesas MCUs. Likewise, even though the class's exercises were developed around Micrium's recently released MicroCOS3 kernel, most of the concepts that I will be covering are not MicroCOS3 specific. The class is meant to benefit any developers who are thinking of using a kernel, one from Micrium or from elsewhere. If you count yourself as one of these developers, then I hope to see you in the class. You'll gain a solid understanding of software that could substantially improve the results of your future development efforts. Thanks for watching, and I look forward to seeing you at DevCon.